In this video, we're going to talk about how to find the area of oblique triangles. And basically, an oblique triangle is any triangle that is not a right triangle. So in the past, we've learned about area of a triangle. We learned the formula area equal to 1/2 base times height. And that required the height to be perpendicular to the base. That's always true about the height of a triangle. That means, again, perpendicular, that they form a right angle. So if we were given in the past, just as a quick example here, a right triangle, and let's say the base was 3 and this was 5, we could very quickly figure out the area and say, okay, let's plug in the base of 3, the height of 5, and we'd get that the area is 7.5 square units. But what about when it's not a right triangle, right? We need another way to calculate the area. So let's take a look at this triangle here, triangle ABC, the big triangle in this picture. If I wanted to find the area of this triangle, I would have to do area equals 1/2 base times height. Okay, so I'm going to walk you through this here. The base is A, the height is H. But I want us to also notice here that if that height wasn't there, we needed a way to actually find it and draw it in. So notice here that the sine of C is equal to H over B. So now let's focus in on this triangle. The sine of C is the opposite over the hypotenuse, so sine of C is H over B. So if we do some substitution here, if area is 1/2 A times H, and we know that H is B sine C, when we cross multiply, when we substitute it in, we get that the area is 1/2 AB sine C. Now this is basically how you derive this formula, but basically this formula is used to find the area of any triangle that is not already a right triangle. And it will make more sense as we walk through some of the problems today. But I just want to point out here in our notes that I have written the formula and its variations. So sometimes the angle that you are given in the problem is angle A, and sometimes it's angle B, and sometimes it's angle C. So you'll see that these vary based upon what angle you're given. So area equals 1/2 AB sine C, area equals 1/2 AC sine B, and area equals 1/2 BC sine A. You'll notice that in each formula, the letters A, B, and C each appear once, and it depends, again, what angle you're looking at. So let's really dive into a question here so you can see how this applies, how we could use that formula and really derive it again. All right, so let's look at number 1 here. Find the area of triangle ABC to the nearest square unit. So I'm going to do this the long way first, and then I'll show you the shortcut towards the end. But if we look at this here, triangle ABC is not a right triangle. If I want to find the base of that triangle, it is 18, okay? So you can make a note that 18 is the base, but the height is not 25. That's a common misconception because remember, the height must be perpendicular to the base. The height of this triangle is really this piece that I'm going to draw in here, and I'm going to show it's the height by drawing in a little right angle, indicating that those are perpendicular. Let's say that I put an H on that measurement here. I'm using H for height. I could solve for what that is, right? So if I look at this right triangle now that I created, so look at this piece that I'm highlighting, the sine of 32, sine of any acute angle in a right triangle is equal to the opposite over the hypotenuse. And if I cross multiply that, I get H equals 25 sine 32. Well, now I know the height, and I already knew the base, so I could find the area of this triangle. So it would be 1/2, the base is 18. The height is what we just found, so 25 sine 32. And I'm just going to put that in my calculator. So I'm going to type a half as 0.5. 1/2 of 18 times 25 sine 32. hit enter, and we're looking to the nearest square unit. So I got 119 square units. Remember, units for area are always squared. All right, so that was the long way. That's using the fact that I could draw in the height, find sine using SOHCAHTOA, and then go ahead and actually substitute it into the area formula. If we want to use one of our shortcuts, and by shortcuts I mean these formulas here, we have to pick which one we're going to use. In this problem, in this picture, notice how we're given angle A. Like we know that that's 32 degrees. That means I want to pick the formula that has sine of A. So that formula would be area equals 1/2 BC sine A. And now I'm going to substitute values in. So B is the side that's opposite angle B, so that's 25. C is the side that's opposite angle C, so 18. Sine of 32. You'll notice that this is the same exact thing, just the 18 and the 25 are flip-flopped. That means, of course, when I put this in my calculator, I'm going to get 119 again. So we could do it by drawing in the height, or we could do it by using one of these formulas. Okay. All right, for number 2, let's try another. We're going to find the area of triangle ABC to the nearest tenth of a square unit. Once again, not a right triangle. So I'm going to walk through this problem by drawing in the height. Okay, and I'm going to call it H. And I'm going to use the right triangle. And when I draw the height, remember it always gives me a right triangle. I'm going to use the right triangle where we actually know some information. On the left side, I don't know anything. But on the right side, I know that there's a hypotenuse of 16. I know that there is an angle measurement of 19. So I see that the sine of 19 is equal to the opposite over hypotenuse, so h over 16. And h is 16 sine 19 then. All right, let's plug that into our area of a triangle formula. So the area is equal to 1/2. The base of our triangle is 29. Remember, we're looking at the big triangle that we're trying to find the area of. The height is 16 sine 19. We're substituting in here. And then I'm going to type that into my calculator. And to the nearest tenth of a square unit, I have 75.5 square units. I will show you the other way using the formula too. So we know angle A here, so that means I'm going to pick the same formula as last time. A equals 1/2 BC sine A. B is the side opposite angle B, that's 29. C is the side opposite angle C, so 16. And sine of 19, you'll see that this matches, and that means we're going to once again get 75.5 square units. So both of these methods are completely valid. Some people like the shortcut formula. Some people find that one actually more confusing because you're focusing more on the letters and actually where they go into the formula, whereas the first way I did it using SOHCAHTOA uses skills that you already know. Okay, but both should give you the same answer. You could even do both ways to check your work. All right, let's try another. Number 3, find the area of triangle ABC to the nearest tenth of a square unit. All right, let's drop down our height. So here is our height. And using that right triangle, I can see that the sine of 41 is equal to h over 15. And when I cross multiply that, the height is 15 sine 41. Now to find the area of this triangle, it's 1/2. The base is 9. The height is 15 sine 41. And I will type that into my calculator. Just a reminder, you always want to make sure you are in degree mode when you are doing these problems. And to the nearest tenth, I have 44.3 square units. If I did it using my shortcut formula, okay, so notice we have our answer. If I use the formula, notice in this problem, we are not given angle A, but we're given angle B. That means we're going to pick the formula that has sine of B at the end. and we'll plug in our value. So this would have been 1/2 15 times 9 times sine of 41, and of course those answers will match. All right, number 4. Find the area of triangle ABC to the nearest square unit. So I'm going to drop down the height. So let's label that height with H, and to find that measurement, we're going to do sine of 37 is equal to the height over 12. Cross multiply, and H is 12 sine 37. And let's plug that into our area formula. Area equals 1/2 the base of 22. We're going to plug that in for our height. So 0.5 times 22 times 12 sine 37. And we're looking to the nearest square unit, so 79 square units. Once again, I'm going to show the formula option. We have angle A in this problem, so that means we want the formula that has sine of A. So area equals 1/2. B is 12, C is 22, sine of 37, and we'll get our 79 units that way as well, square units. All right, our last example, number 5, is a little bit different. It says to find the area of the parallelogram to the nearest square unit. All right, so I'm going to do this both methods, just like I have for the other questions. However, you're going to notice a little bit of a difference between the two methods here and just how we're going to work with them. So let's say that I'm going to start off using the method where we drop down the height, we create our right triangle and our trig equation using SOHCAHTOA, and we plug into the typical area of a triangle formula. I'm just going to focus on the triangle for this portion. Okay, so I'm looking at this piece here, and I'm just going to slide this over. Okay, so I'm going to forget about the parallelogram for a moment. I know that this is 14. Let's neaten that up. So this is 14. I know that this is 20, and this angle is 118. All right, so based upon this, the base of the triangle is 20. The height is a little tricky and a little different to draw here, though, because the height has to go from the top point to the bottom point, but that really means that the height is going to be outside the triangle. So if that confuses you when you draw down that height, if you want to draw it as a dashed line, in fact, you could do that in all of the questions if you want. That's perfectly fine. Okay, and I'll draw in my right angle here. So that is our height. And here's one main difference with this parallelogram problem compared to the others. And really, this is going to be any where the angle is obtuse, like the 118 is here. This angle over here is 62 degrees, right? Those are supplementary, and that 62 is really the one that's in the right triangle, not the 118. So sine of 62 is equal to the height over 14. The height is 14 sine 62. All right. So when we are plugging this into the area formula, it's 1/2, the base is 20, the height is 14 sine 62, but let's hold on a second. Remember our original picture. It's a parallelogram. A parallelogram, the diagonal splits it into two congruent triangles. So really what I have here, that's the area of the triangle. I'm going to have to double that to get the parallelogram. And you might not even notice here that this 1/2 and 2 are going to cancel out in a way, right? They're going to multiply and be 1. So I'm just going to type in my calculator 20 times 14 sine of 62. Hit enter, and I get the area is, we're rounding, let's see, in the nearest square unit here, 247 square units. So the difference here is because we had an obtuse angle. Yes, because of the parallelogram, there was the difference of doubling, but we had the other difference here of the obtuse angle. We had to use its supplement to use the right triangle method. All right, if we go back to our formula method, we are given angle C here. So that means I want 1/2 AB sine C. but that would give me the area of a triangle. I need to double that to get the parallelogram. And you're going to see that these 2's and 1/2 will once again cancel or multiply to 1. So really we're looking at AB sine C to find the area using the formula. A is going to, in this case, be one of the sides we're looking at. In this problem, we are looking at, I guess if you really want to look at it here, we really have DBC. So I'm going to use 14 in here. Right, so I'll make this a D just so we can look at triangle DBC. And then sine of C is sine 118. All right, putting that in our calculator, you're going to see we're going to get the same answer in a moment. So 14 times 20 times the sine of 118 will give us our equivalent answer of 247 square units. Okay, so again, in this video, hopefully you were able to understand how to find the area of oblique triangles using 2 different methods.